Hi guys, in this video we're going to discuss what exactly a function is in high school mathematics, and the best place to start is with the definition. Now please note that there are many definitions for what a function is, but I hope this one helps you understand it the best. It says that a function is a specific mathematical relationship which involves two variables, namely x and y. Now please note that x and y are going to be the most common types of variables that you will be working with throughout your high school life, where x represents the input variable and y represents the output variable. So in short, a function takes an input number, transforms it through some mathematical relationship, and the resultant number is known as the output. You may be familiar with this example that you would have seen in your primary school days, where the teacher would give you some kind of mathematical transformation and would ask you, if you input a certain number, what would the output number be? In this example, if you input the number 2, you would multiply it by 3 and add it by 4, and your resultant number would be 10. This equation represents this entire math transformation. If we had to take a more generalized scenario, and instead of inputting a 2, let's put an x into that same transformation, where we would take x, multiply it by 3, add a 4, and the resultant number would be a y. This equation below represents this entire transformation. This equation is what we call a mathematical function. Now, throughout your high school life, there are going to be four main functions that you are going to be most concerned with. And the first one, you should be familiar with it, is known as the straight line function. And it always appears in the form y equals mx plus c, where m represents the gradient of the line and c represents the y-intercept. The second function that we are most interested in is known as the parabola or the quadratic function. And this is always denoted by the equation y is equal to ax squared plus bx plus c. In your grade 10 year, when you are being introduced to the parabola, the b value, the b parameter, will be set to 0. Therefore, the equation is always reduced to y is equal to ax squared plus c. The third function is known as the hyperbola, and this equation reads as follows: y is equal to a divided by x minus p plus q, where p is known as your horizontal shift and q is known as your vertical shift. The last equation is known as the exponential function, where the equation reads as follows: y is equal to a multiplied by b to the power of x plus q, where b cannot be equal to 0 or greater than 1. Now please note that the thing that all of these equations have in common is that they all contain an x and a y, and they are always read in terms of y. And the reason for this is because in the section of functions, we want to take an algebraic representation and transform it into a graphical representation. And the way that we do that is through the use of a Cartesian plane, which, as you know, is a combination of an x and a y axis, moving horizontally and vertically, respectively. Over here, you can see our Cartesian plane. And our Cartesian plane is always followed in this exact layout, with the centermost point known as the origin, containing the coordinates 0 and 0. In this example, if we want to plot the straight line, y is equal to 2x plus 1. First of all, we need to start using functional notation. Now, functional notation does not change the algebraic representation of what we are talking about. All it's going to change is this y value and the way that we write it. Imagine we wanted to plot multiple graphs on this Cartesian plane: a straight line, a parabola, a hyperbola, and an exponential graph. We cannot refer to those graphs all as y. We need to rename those graphs to specific functions. So, for example, we could take our straight line and call it f of x. We could take our hyperbole and call it g of x. We could take our parabola and call it h of x. This is mainly to avoid confusion when referring to the graphs that we are talking about. And the graphs obey the same laws as always, In plotting them, if we have to take a specific x value, the graph will always output a specific y value, and this is known as a coordinate. Remember, coordinates always work on the basis of x and y. When we write out f of x is equal to 2x plus 1, let us say for argument's sake that we want to plug in a point. Let us find out where the graph is when x is at the value of 1. We would say f of 1 is equal to 2 multiplied by 1 plus 1. Wherever I see an x, I would replace it with the number 1. And I would get an answer of 3. Therefore, the graph would intersect at a coordinate 1 and 3, where 3 represents the y value and 1 represents the x value. We need two points to plot a straight line. So let us take another random point in space. Let's find out what happens when x is equal to negative 1. Well, negative 1, I would say f of negative 1 is equal to 2 minus 1 plus 1 gives me a resultant factor of negative 1. Therefore, this coordinate would be negative 1 and negative 1. I would plot those two coordinates and be able to plot my straight line from there. In my next video, I would like to discuss the straight line graph and its various properties. So I thank you for watching and stay tuned.